All right, hello geometry students. We are now moving on to Unit 4, and I'm going to be focusing on two important aspects of 4, which is on triangle congruence. So just a couple of things to remind you all is that the sum of the interior angles of a triangle add up to 180. So you just need to figure out the missing angle by just doing 180 minus whatever two angles you are given. That's just kind of a heads up on that. So you should remember all of your triangle properties. So, you have three angles inside a triangle. And so we're going to be utilizing that for triangle congruency theorems. So what is triangle congruency? You are proving that triangles are congruent. So in Unit 3, you are proving that lines are parallel by certain properties. You are now going to be proving that triangles are congruent by certain properties. And so there are 5 total properties that we will be focusing on. Okay, they are side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. Those are the 5 properties that we will be working with, or the 5 theorems that you will be working with. I will be going into detail on each one, but before I even do that, we need to go into a little more detail onto how we can utilize these properties and how you get these properties. So in order to do that, I'm going to start by showing you 2 triangles. So we have triangle here, which we will label as triangle ABC. And we have a second triangle, which we will also label as triangle D, E, and F. So in order for you to determine if triangles are congruent, you need certain characteristics to be true, or certain aspects to be true. So you'll be seeing essentially you'll be seeing 2 triangles given to you at specific for specific questions and for specific proofs. So what you need to know is kind of the relationship between 2 triangles. So in the case of this triangle here, ABC, and the triangle DEF that's given, you can make some comparisons between the two in terms of angles and sides. And this will help us when we are determining whether a triangle is congruent by these 5 properties that I listed. So some things to keep note of is that if we are trying to prove that triangles are congruent, we need certain aspects to be congruent. And so if we are given these, then we are able to list that the triangles are congruent. Now, a helpful hint to note is that we are going to be writing congruency statements. So to kind of illustrate this, I'm going to give you a congruency statement. So here's the congruency statement that you will be using to prove that triangles are congruent. So for the example, just to see, triangle ABC is congruent to triangle DEF. This is what we call a congruency statement. So this is what you will be writing when you are determining if you actually get a triangle to be congruent to another one. You will write a congruency statement. Now, when this happens, so if you're ever given a congruent statement, you can write down what angles are congruent to each other and what sides are congruent to each other. So given a congruency statement, you can list it. Now, how does this work? Order is important. So one thing for this unit that you need to write down in your notes and keep track of is the fact that order matters. When you are listing that 2 triangles are congruent to each other, order matters. Okay, so I'm going to shrink this a little bit and move it over, because now we're going to begin listing the congruent parts. So we are going to list now the congruent parts of these 2 triangles. Okay, so because we have written the congruency statement, or I gave you the congruency statement as A followed by B followed by C, and then D followed by E followed by F, we can now make the following comparisons. Angle A is congruent to angle D because A came first for the first triangle and D came first to the second triangle. So those angles are congruent to each other. Therefore, angle B is congruent to angle E because B is second, E is second, they are congruent to each other. And then angle C is congruent to angle F because C is third, F is third. So on a triangle, when you are labeling, okay, labeling the two angles are congruent, you put little arcs inside. So A is congruent to D, B is congruent to E, I'll put 2 arcs to show that those angles are congruent. And then C congruent to F, I'll put 3 arcs to show that these are congruent. Okay, so this alone from the congruency statement tells me that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. They relate to each other. Okay, so it's kind of like matching. We're matching up what is congruent. We're matching up what is the same. So that's for angles. The same thing can be done for the sides. Okay, and again, I'm going to reemphasize this: order matters. Okay, so if I'm looking at segments, so now I'm looking at line segments here. Okay, so the segments of the triangles themselves, I can make the following comparisons. Okay, segment AB. Okay, so segment AB, so that's AB here. That's going to be congruent to segment. Oops, that is not a congruency symbol. That is going to be congruent to segment DE because A is followed by B and then D is followed by E, so that segment is congruent. And I can note that by putting a little tick mark. Okay, so those segments are congruent to each other. Similarly, I can say that segment BC is congruent to segment EF. Again, because of order, BC comes in that order and then EF comes in that order. So BC is congruent to EF. So I can put 2 tick marks to symbolize that those segments are congruent. And the last connection I can make is that segment AC is congruent to segment DF. So AC is congruent to DF. So in this listing, I've listed all the possible scenarios or situations to where segments can be congruent to each other or angles can be congruent to each other. So this is just off of the congruency statement where I told you triangle ABC is congruent to triangle DEF. You can make these comparisons. Okay, when you're given a congruency statement, you can make the comparisons that certain angles are congruent to each other and certain segments are congruent to each other. And this is what is going to be beneficial and helpful to you when we are proving that triangles are congruent. Because certain situations, you're going to be given certain information, and then from there, you will be able to determine if 2 triangles are congruent or not. So this is kind of the background information, okay? Is understanding that if you are given a congruency statement, you can break it down into, I can match up angle congruencies, and I can match up segment congruencies. So from here, now I'm going to show you and illustrate to you each of these 5 properties and how, when you see them visually, you can determine that 2 triangles are congruent. And this will come in handy when we get to the proofs part of this unit. So you're welcome to pause the video here and finish copying these notes down. But I'm now going to move on into each of these triangle congruency theorems, starting with side, side, side. All right, so the first triangle congruency theorem is side, side, side. Triangle congruence theorem number 1 is side, side, side. right? So essentially how this works is that if you are able to determine that three sides of one triangle match up and are congruent to three sides of another triangle, you have triangle congruence. So again, I'm just going to use the two triangles I showed in the previous example. I have triangle ABC, and I have triangle DEF. And let's say that I have that AC is congruent to this side DF. I have BC is congruent to EF, and I have AB is congruent to DE. Excuse me. If I have this situation where three sides of one triangle are congruent to three sides of another triangle, they match up, okay? So I can write down here, okay, if I go in the order of A followed by C followed by B, then if I follow that order, I can match that by saying I go in the order of D followed by F followed by E. Then I can say that those two triangles, triangle ACB and triangle DFE, are congruent to each other by the side property. Okay, so once again, I'm just going to reiterate this as I go piece by piece. So once again, if you're given three sides of one triangle and it matches up with three sides of another triangle in terms of matching up congruence statements with the segments of the triangle, then you can prove that the triangles are congruent by side. So A to C matches up with D to F. Okay, that one tick mark shows that those segments are congruent. So A to C matches up with D to F. C to B, that segment matches up with F to E. And then B to A matches up with E to D. So then knowing that if I go in that order of A followed by C followed by B, then D followed by F followed by E, that triangle will be congruent by side because I'm given that those sides are congruent to each other for each respective piece of the triangle. Okay, so that is side. All right. So the next one, congruence theorem number 2, is side angle side. So I'm going to erase these little tick marks. That did not work. All right, and then we're gonna go ahead and erase this too. All right, so the next one is side angle side. And that is the theorem number 2. So in this case, this is what I like to call the side angle sandwich. Okay, you have two sides and then sandwich between them is an angle. So it's the side sandwich, I like to call it. Okay, so this is kind of the nickname I give for this theorem. And the reason why is because you're going to be given two sides. So let's say AB is congruent to DE and BC is congruent to EF. And then in between those sides, there is an angle that I know is congruent. And in this case, that's angle B congruent to angle E. So if I'm given this information, I'm given these three things. I'm given AB is congruent to DE, BC is congruent to EF, and angle B is congruent to angle E, then I know I can write the following congruence statement. Triangle ABC is congruent to triangle DEF, and that is by side angle side. Again, you have two sides, and in between those two sides is an angle that is between them. So the sides are like the bread and the angle is the meat. So it's a side sandwich, okay? When you have this scenario, then you know that you have side angle side. You can prove two triangles are congruent by side angle side. So once again, you're given two sides, okay? Doesn't matter what the two sides are, but if you're given two sides and you know that those sides are congruent to each other, and then you have an angle in between those two sides, then you have side angle side, and you can prove the two triangles are congruent, okay? So that is the second theorem. The third one is now kind of switching things up. So we focused on the side aspect. The next two are focusing on the angle aspect. So the third angle theorem, okay, and I'm going to completely erase this because it's going to change all of this. And I just need to erase the tick marks and the angles here. And that did not work out the way I wanted to. Thank you for your patience. Okay, so the next one is congruence theorem number 3, and this is angle side. And so here the focus is now on the fact that I'm given two angles and a side. So given two triangles, if I know that, let's say, angle A is congruent to angle D, and then I know angle C is congruent to angle F, and I also know that side BC is congruent to side EF, okay? So if I'm going to start with angle A, going in the order of A to C, and then C to B, if I follow that pattern, I have angle congruent to angle, I have another angle congruent to an angle, and then I finish with a side congruent to side. That is angle side. So I can state here that triangle ACB is congruent to triangle DFE by the angle side theorem. Okay, so once again, you're matching up what is congruent. So the fact that they tell you angle A is congruent to angle D because they both have one arc that symbolizes they are congruent. Then you have angle C is congruent to angle F because they have two arcs, which symbolize that those two angles are congruent. And then you know side FE is congruent to side CB because it has one tick mark. Okay. Then you know that those two triangles are congruent by angle side. And that is enough to prove that the triangles are congruent. Okay. That's the third one. The fourth one is just a slight variation. Okay. So I showed you just recently the side angle sandwich. Now I'm going to show you the angle side sandwich. And then this needs to be erased. That needs to be erased. We'll erase this. And then we'll erase this. We'll erase this. We'll erase the arrows and the arrowheads. Okay, so now this one is called angle side angle. So angle side angle. And this I give the nickname of the angle side sandwich. Okay, because now I'm given two angles and then sandwiched between them is a side. So that will be the following situation. Let's say I tell you angle C is congruent to angle F, angle B is congruent to angle E, and then in between those two angles, I know CB and FE are congruent. Okay, when this happens, and going in order from, in this case, I'm going right to left, or you could go left to right, it doesn't matter. But you notice that it's an angle first, then a side, then another angle. The side is sandwiched between the two angles. So the angles are now the bread, and the side is the meat. Okay, so I can say here that triangle, I'll kind of make it go in this order. BCA is congruent to triangle EFD, and that is by angle, side, angle. So again, angles on the ends, and in between those angles is a side. And again, this is all related to congruency. So if you know angle B is congruent to angle E, you know angle C is congruent to angle F, and you know side BC is congruent to side EF, as given to you, then you can prove that these triangles are congruent by angle, side, angle. Oops, this is congruence theorem number 4. Okay, so this is the fourth congruence theorem. So there's one more. Okay, and that one is a special case. This is what for a special case for special triangles, and this is hypotenuse leg. So I'm going to erase all this, erase all this. And I'm also going to erase the triangles because now we are going to be given a specific scenario. Okay, so this is triangle congruence number 5, and it is called HL, which stands for hypotenuse leg. And the special case is this. It is for right triangles only. All right, it is for right triangles only. So now I have a specific scenario where this could happen, and it is when I have two right triangles. Okay, so I have two triangles, they're both right triangles. Okay, this is the scenario that has to happen. Each of the hypotenuse, or each hypotenuse of each triangle, has to be congruent, and then one of the other legs of the triangle has to be congruent. So let me label this. This is A, B, C, and this is D, E, F. As long as I know that the hypotenuse, so in this case, AC is congruent to DF, as long as I know the hypotenuse of each triangle is congruent to each other, and then I'm given a leg that matches up in congruency, I know that these triangles are congruent by hypotenuse leg. So the triangle congruency statement I can say here is that triangle ACB is congruent to triangle DFE, and that is by hypotenuse leg. So those are the 5 congruence theorems that you'll be utilizing throughout this unit to prove that triangles are congruent. Okay, there is going to be homework related to this. There will be a worksheet that we'll be working on in class. So that means you need to be watching this video ahead and taking notes, because what we're going to be doing in class is practicing this to get you acquainted with identifying these 5 properties. Okay. There is another video coming that's going to go over the proof side. So you're going to have to prove that triangles are congruent. So there are going to be some 2-column proofs that we're going to utilize or do examples on in the next video so that we can work on those in class as well. This entire unit is just going to be working on identifying and understanding triangle congruency, how that works, how it operates, and then from there, you're going to be practicing how to prove triangles are congruent by utilizing these 5 properties, and then actually writing proofs. Some from scratch and then some filled in, as you've done before. So this is the first lecture video. There will be a second one following. I'm also going to attach a couple YouTube videos that give a different aspect to this property, to these 5 properties. So within this video, this is the lecture video that I want you to take notes on. I'm going to also give you 2 resource videos in relation to this. You can tack on additional notes. But this is the first lecture video. There will be a second one following. And please make sure you have these notes written down and ready for you to practice in class when we get back to after your test, which will be on Wednesday. So we will be starting this unit on Wednesday, so please be ready with notes and with questions, because when you come to class, we're just going to be practicing and getting you accustomed and acclimated to this process. All right, guys, see you soon.